All right, so we didn't quite get to this one yesterday. I want to make sure we do one like it because there's at least one kind of like this on the homework, and they look really, really, really scary.
They are scary.
Once we get through it, I promise it's not the worst. It's not horrendous. But that's why I want to do it together, so that we have something from which to structure what we're doing. Okay? So we look at this and we go, ew, right? I know. So first things first, I see subtracting in this numerator. So we're going to simplify that thing first before we deal with any of that divide by h mess. Okay, so I'm going to pull that guy out and we are going to do that subtraction. So I'm just going to write the numerator piece over here. 3x plus 3h minus 1. 4 over. What do we need to have to be able to subtract those two pieces? Common denominator. These denominators are kind of gross. So we're just going to take the whole chunks. This left one we need to multiply by 3x minus 1 over 3x minus 1. The right one we're going to multiply by the whole hot mess over there. 3x plus 3h minus 1 over 3x plus 3h minus 1. This guy just means 1. He's gross looking, but he just means 1. It's the same thing top and bottom, right? What that gives us is a common denominator of 3x plus 3h minus 1 times 3x minus 1. So we have that common denominator. And what we're going to do is we are going to kind of do our distributing at the same time. So we have 4 times this guy. 4 times 3x gives us 12x minus 1. And what's up? 4. Just making sure we're paying attention. Totally intentionally making sure we're paying attention. Y'all, it happens. Nobody's perfect. Call me out. And honestly, that's where we see a lot of mistakes is we like, oh, I've done the hard part. Distributing. Kicks us in the teeth. It happens. Luckily, partial credit's a thing, and like that would be like half point is what that is. All right, so we're going to take this minus 4, and we are going to distribute that sucker. So we are subtracting 4 times 3x, 12x. We are subtracting 4 times 3h, minus 12h. Minus 4 times minus 1 gives us plus 4. Do we see how all of that combined there? Because I kind of did, again, like 3 steps at once. We combined things together, we distributed, and I distributed the minus sign. So that was a lot of steps all at once. So now we're just simplifying this numerator. You okay? You good? Okay. It was just very dramatic, so I had to check. All right, so in this numerator, I've got 12x minus 12x. They go away. I have 4 and minus 4. They go away. So what we have here is minus 12h over that hot mess of crazy. 3x plus 3h minus 1 times 3x minus 1. Remember, all of this is still being divided by h. This is just our numerator. All of that divided by h. So instead of writing as a giant fraction, I'm going to go like this. Divide by h. Or we can think, well, wait, division, keep, change, flip. So that whole fraction times 1 over h. So I'm just going to erase and write that because I don't want to have to rewrite the whole dang fraction. Times 1 over h. I'm going to give us a little bit more space so we can see that, right? What happens there? The h's cancel. I've got a single h on the top and an h on the bottom. So our answer here is negative 12 over hot mess. 3x plus 3h minus 1 times 3x minus 1. That's a minus. And that's our answer. Okay? I wanted us to have one of those in our notes somewhere so we could kind of use that as a basis for the grossy fractions. Okay? Because they look really scary. Break them into pieces. Deal with your numerator. Deal with your denominator. Then smush them together. Okay? Because what we're going to do, I actually have to make the screen blank for a second. So does everyone have this written down? Because I'm not going to be able to come back to this one for a hot second. Okay. I just didn't want us to truck on without touching on that so that we didn't freak out. Because now we're going to figure out how to rationalize when there's adding and subtracting. So to get the square roots away when there's adding and subtracting. And I know the words are very small. I just wanted to make sure we had space enough to write stuff on my screen. So rationalizing a fraction with a binomial in the denominator. It's a lot of multisyllabic words. To get rid of roots when there's plussing and minusing, if you want smaller words. We're going to multiply by the conjugate. Conjugate is going to be a word we're using a bunch. So that's like if you get one word off of this page, it's going to be conjugate. And what a conjugate is basically, we're going to think about difference of squares. Because I would like for those guys to both be perfect squares. And I'm going to multiply by something that makes them perfect squares, but doesn't give me a bunch of terms in the middle. So the conjugate on this, what we're going to do is we're going to take our square root of x and our square root of y with a minus sign. It's always going to have the opposite sign. Because if I multiply square root of x minus square root of y, remember we're multiplying by 1. It's just the weirdest looking one. Yes,
So the conjugate is just when you
flip the sign
in the denominator.
in either one. We're going to have to do both numerator and denominator because the book is extra. So the conjugate is this piece. Just that piece is the conjugate. We're multiplying by 1 using the conjugate. But we're multiplying by the conjugate. And we will see why in just a second, I promise. Because if we look at both of those and we look at that denominator, and we think about what happens when we multiply those two dang things together, we have square root of x times square root of x, which gives us just x, right? We'd have square root of x times the square root of y minus square root of x times the square root of y minus y squared. I don't know why that has a bar. Right? You see what's going to happen with the x square root of x square root of y? Those guys cancel out. Oh, not y squared, just y. Sorry. Square root of y times square root of y is just y. The first x came from, square root of x times square root of x was this guy. And then square root of x times minus y gave us this one. Y times square root of x gave us this one. And y times y gave us that one. So I know I just got a very, very arrowy up there. But do we see where those pieces come from? And then when we simplify, our denominator turns into x minus y. And our numerator, 1 times square root of x minus square root of y. You do not have to write out that middle step. It was just showing you this first time. This step, you do not have to write out. It was just showing us what's happening. We made difference of squares just with a gazillion square roots. Okay? I just didn't want to go from the first one to the last one and say, magic! Okay, so we see the step. Don't have to write that step unless we really, really feel the need to. You can. If it helps you, do it. More power to you. Never fault you for writing more steps. Okay, but we're going to practice using that conjugate to rationalize. Are you ready? Okay. So this specifically says to rationalize the denominator using the conjugate. So we're getting the radical out of the denominator. I made sure to make that clear because in the book, and later, we're going to also have to rationalize the numerator because choices. I did go check with people as to why we do that, so I'll tell us. Okay, so what we're going to do is we are going to take whatever our denominator is. It's going to have those same terms, square root of a and 3, but it's got that opposite sign. And then since I cannot change my expression, I have to make it so we're multiplying by 1. Multiplying by that, right? When we do this multiplication, what are we going to get in our denominator? Square root of a times square root of a. A. My two middle terms are going to cancel out because it's difference of squares, because that's literally our design. What's our last term going to be? Minus what? 9. 3 times 3. Our top one, our numerators, is regular distribution. And it's going to be not pretty, but it's a thing. So square root of a times square root of a gives us a plus 3 square root of a plus 3 square root of a, 3 square root of a, plus 3 square root of a, plus 9. Boop, boop, boop. Oop, that's wrong. We distributed. Square root of a times square root of a gives us a. Square root of a times 3, 3 square root of a. 3 times square root of a, 3 square root of a. 3 times 3, 9. Okay? Does that fix the what's I heard? Because I heard like 6 of them. Okay? It's okay to toss out a what. I will then go and explain. And then all we have to do is simplify. Because I can combine together my 3 square roots of a to be 6 square roots of a plus 9 over a minus 9. Can y'all tell the difference between my a's and my 9s? Okay. Because I have a different way to write a if I need to, but it makes things look weird. Because you can do the Times New Roman a. I can do it. It's just weird. Looks kind of like backwards 6s then. I did it in my notes because I genuinely could not tell which one was an a and which one was a 9. Okay, so that is our answer for this one. That is rationalized denominator. We rationalized our denominator here. So rationalizing the denominator is where we get the square roots out of the denominator. We've done rationalizing the denominator a couple of times in a couple of different ways. Occasionally, because the book likes to make choices, we're going to be asked to rationalize the numerator. Genuinely had to go ask other people why they wanted you to do that. It's just because we're practicing it so we know how to use a conjugate. Okay? Yes. I'm not saying that, but I am going to agree with that. Okay, so I genuinely went and asked other people, why are they making us do this?
Like who? Like mathematicians?
The book.
Oh.
The book is making us do this. Because genuinely, in my entire life, I've never rationalized a numerator before. In my 3 years of calculus, we've never had to do it. And I went, why? Okay? Because the book likes to make choices. We're going to do it. But it's a choice. It's a choice. They made a choice, and they're sticking with it, but it's a choice. Okay. So what we're going to do is we're going to rationalize the numerator. We're going to get the roots out of the numerator because of reasons. So we're going to use the conjugate, which means I'm going to take my two terms, square root of a and my square root of b, and it's going to be a plus instead of a minus. But because I can't just multiply by that, we have to multiply by 1, and it's just a weird one. So we're multiplying by our conjugate. Same terms, opposite sign. So when we get to our next step, our numerator this time is the one with the opposite signs, with our difference of squares. So our numerator is going to be square root of a times square root of a gives us a. Square root of b times square root of b gives us b. It's a difference. If you need to write the whole thing out and distribute it and simplify, 100% fine. It's difference of squares. Yes, my friend.
When we do this, is it always going to be minus?
It always will make us a difference of squares when you use your conjugate. Because the point is for those to be the exact same terms with the opposite sign so that those middle terms disappear. As the whole point is to make it difference of squares. Speaking of difference of squares, in our denominator, a squared minus b squared is another difference of squares. So they're wanting us to factor that term. Don't just distribute through. Because what we have here is our a squared minus b squared, which we could write as a plus b, a minus b, times that conjugate. Square root of a, come on, pen, stop being a jerk. Square root of a plus square root of b. Bunch of pieces there. You okay on that? Make sure we see how we got from here to here. Sometimes they'll ask us to factor in the middle, because if I factor in the middle like that, what can I do? Cancel out my a minus b. And we're left with 1 over a plus b square root of a plus square root of b. And we can leave it like that. You do not have to remultiply stuff out. Okay. All right. How we feeling on that one? Okay. Because we've got another one. It's not the worst one for today. We have one more that's grosser. And again, we're rationalizing our numerator. So we've got the square root of x plus h minus the square root of x all over h. And we are using our conjugate to do this. So we're going to take our numerator, since we're rationalizing our numerator, and we're going to take those terms. Square root of x plus h and square root of x. We are not changing anything inside of a root. We are only changing what's between the roots. I didn't even touch the board. So this becomes a plus here. It's just the piece between your roots. And then our denominator of that piece is exactly the same. Okay. So when we do this and we multiply these together, square root of x plus h times square root of x plus h is x plus h minus square root of x times square root of x, x. Over, our denominator becomes h times hot mess square root of x plus h plus square root of x, like that. Okay there. That's the hard part on this one. What can I do with my numerator? Cancel out what? The x's. I've got x minus x. Bye-bye, friends. What else can I do? The h's. I have h on the top times h on the bottom. Boop, boop. So it leaves me with a numerator of 1 over hot mess of square root of x plus h plus square root of x. Okay? So not the worst thing ever. Looks really, really scary. Very impressive to look at. But not the worst thing ever. Just going to say it before I turn the page. Okay. We're rationalizing the numerator. It's not that much more. It just has a couple of 2's in it. I just inhaled my coffee. Yes, dear. I was gonna say I'm gonna look at the thing. I believe Thursday. Thursday. This Thursday. This Thursday. And it'll be over. The conjugate will most likely be on it. I haven't seen it yet. So I'm gonna go with most likely. I'm not making any promises.
Is this next or just the
It'll be the 1-3-1-4. And we are finishing up 1-4 today.
Oh,
Okay, we are finishing 1-4 today. This is our last one with the conjugate today, and then I'm going to show you 2 things from the homework that you know how to do, but we just haven't talked through how to do specifically. Okay? So this is our last one with the conjugate today. Therefore, you can assume this is probably like the hardest kind of one with the conjugate. Okay? I'm not going to end with the easiest one. So we're going to take our numerator, because we're rationalizing our numerator here. And we're just going to take it as it is. Square root of 2 times the quantity x plus h plus 1. And our other term is the square root of 2x plus 1. Whew. And it was a minus, so now we use a plus. And we're multiplying by the same dang thing again. 2 times the quantity x plus h plus 1 plus square root 2x plus 1. Okay? Just each of these pieces. So piece 1, piece 1. Piece 2, piece 2. That one had a minus, that one had a plus. All right, so our numerator is going to become, our first piece is that 2 quantity x plus h plus 1 minus, get a different color, green, 2x plus 1, right? Okay, on that part? Okay. Our denominator, we do h times hot mess. Square root 2x plus h plus 1 plus square root x plus 1. Once you get this step, you've done the hardest part. Finding the conjugate and multiplying your numerator, which is difference of squares. Then we have to just simplify our numerator a bit. So when we do that, we have 2x plus 2h plus 1 minus 2x minus 1. Our denominator's still the same. If you just want to like write that, like you can just do that. Whatever you do on your homework is fine. As long as your final answer has it, you don't have to rewrite it a gazillion times if you're not playing with it. Because what does our numerator simplify down to? I've got a 2x minus 2x. Those guys go away. Got a 1 and a minus 1. Those guys go away. And we're left with the numerator of 2h. 2h over h times. See what's happening here? I can see what's happening. All right, what's happening? Making it so we can see it. I have one last thing I can do here. What can I do here? Cancel the h's. I've got an h on the top and an h on the bottom. And we have our answer. 2 over whole hot mess of crazy. Square root of 2 times the quantity x plus h plus 1 plus square root 2x plus 1. And it does not look better, but it is. It's a lot of pieces. It's all about that conjugate. Okay. How are we feeling about our conjugate? Okay. Okay. Because the last two pieces on the homework feel like they're coming way out of left field. Like they feel really, really different. Okay? Because there's no conjugate. Okay? Express as a sum of terms. Is what this says. It says express as a sum of terms of the form ax to the r, where r is rational. We're going to get rid of the denominator and write this as a polynomial with fraction roots. We've done these before. It's just saying it weird. Okay? So I'm going to start out writing it like we're simplifying. So I'm going to write this as 4x squared divided by x to the 2/3 minus x divided by x to the 2/3 plus 5. Oh, sorry, cut off that thing. Oh, over x to the 2/3. Okay? Write it like we're simplifying. And then we're using our exponent laws to combine our x's together. Yeah, totally fine. We're going to use our exponent laws to kind of combine these together. When I have an x in the numerator and an x in the denominator, what do I do with their exponents? Subtract them. So this becomes 4x to the 2 minus 2/3. If you don't need this step, you don't have to write it. And x to the first minus 2/3 plus 5x to the minus 2/3. And then all we need to do is simplify those exponents, because I don't like these operations in these exponents because they look weird. Because the 5x to the 2/3, or x to the minus 2/3. I just brought this x out because we want no more x's in the denominator. So we have 4x to the 2 minus 2/3 1 1/3 or 4/3 minus x to the 1 minus 2/3, which is 1/3 plus 5x, I can't simplify this at all, minus 2/3. And that's the answer they're looking for here. Okay? It feels like it comes way out of left field. And looking at the problem, you go, wait, what? When we're doing it in this homework. So I wanted us to see one like it. The last one we have is really, really weird. And they have at least one like it on the homework. It might be two like it on the homework. And this is, I believe, the one in between the two on the homework. I'm going to say it looks gross. And it kind of is gross. But I want us to see it, okay? Breathe. This is one problem. That's why we are doing one together. Because there's at least, I think there's two like this on the homework. Ugh. Guess who didn't get to design the homework? Guess, because IU does. I don't get to design it. So we are doing one like it because it's like there's one like it on the homework. Okay? Breathe. I promise we'll go through it. I promise, I promise, I promise. And just so that we're aware, PhotoMath is not entirely sure what to do with this either. Just as a warning. No, I totally don't know that because I totally didn't PhotoMath this myself. PhotoMath don't know what to do with this. Just saying. We got it. We figured it out. But just so we're aware, PhotoMath don't know what to do with this thing. It has no idea. It has no idea. It gives you a thing, and then I think there's even a question mark after it where it goes, Okay. So what we have here is a lot of pieces added together. One thing, another thing, added together. Okay? And we're just told simplify. So the one thing we see in here, I see on this right-hand side a negative exponent. Okay? So what I'm going to do is I'm going to take this right-hand thing and write it as a fraction. Because what we have here is x squared minus 4 to the 1/2 in the denominator. Remember, 1/2 as an exponent means square root. You can do it as a root if you want to, or you can leave it as an exponent. The other pieces we have in the numerator, we have our 2x plus 1 cubed. We have 1/2 2x. So just as a way to get life to be simpler, 1/2 2x. 1/2 times 2, 1. I can lose those numbers. They're in the way. I don't like them. And we have our x, which you don't have to have in parentheses, but you can. Okay? Are we okay on how I found that right term? It's a lot of pieces. This is just from the plus sign on. This is just from here on. Okay? To deal with the left-hand side, I don't have any negative exponents, right? We are asked to add them together, which means they need to have what? A common denominator of that. This guy doesn't have a denominator, right? There's no negative exponents anywhere. This is all numerator. I need it to have this so I can add the dang things together because of choices. So if I need it to have that denominator, we got to multiply by the denominator. like over itself. So it's 1. It's just gross. And it's gross. It's gross. Okay, so we're going to take this whole term and multiply it by x squared minus 4 to the 1/2. That's not a 1/2. Over x squared minus 4 to the 1/2. I'm multiplying this whole piece by it. This whole blue chunk. Right? Oh, wow. We'll finish it tomorrow. Okay? We will finish this one tomorrow because it's grossy. Okay, so this will be the last, I believe, 2 on 1/4. So that means you'll turn 1/4 in on Thursday so that you have a day to work on these 2 because they're gross. Okay, since we didn't get all the way through it, I'm not going to make you try and rush into it in class tomorrow because we don't have time. So 1/4 you'll turn in on Thursday unless you get it done a little early. Bye! I would love to get your homeworks back to you. My pile